Welcome everyone to our presentation. Our project is a web scraping project called Scoutsman, created by me, Joseph, Daniel, Nicholas, and Quentin. The problem. The problem right now is the access to data during the pandemic. There is a large difficulty to accessing vital data online during the COVID-19 pandemic, such as the pricing of health and sanitation products, job opportunities, testing site locations, insurance coverage, and price. This lack of data causes many difficulties for researchers and for the public. The researchers can't closely study the pandemic without the centralized data, and as well for families that are just struggling during these times, they need information for all these products and other services. Our solution. Scoutsman aggregates data across thousands of web pages and centralizes it on our web page. This allows our users to obtain and sort through the data that we collect. Our initial approach contained many difficult choices. We had to choose between tech options such as a framework versus libraries, how to simulate a web page, avoiding anti-bot protection services on sites such as Amazon, or local/cloud-based scraping. Our final solution, we decided to collect the data on our web scraper in the cloud, export the data in a JSON file, and then use the data in the JSON file to present the data on our website.
So for the more specific technology we mainly used two Python libraries, Request and LXML. Request is a library to make HTTP requests such as GET and POST, and that is just necessary to get the HTML from the web server into a Python program. And from there, we used LXML, which can parse HTML and other hierarchical data structures. And you can then query it with a variety of languages and tools, but XPath is by far the most popular and powerful because it is very extensible and it is also built for HTML. So you can get every single piece of data you need from a web page. A tool that, if we went further in this project, we will most definitely use is Selenium because it simulates and drives a web page, which is essential for getting around anti-botting. Because the request is not actually simulated, it just makes a GET request. But Selenium pretends that you're an actual user, and you can use other techniques such as spoofing your user agent to trick the browser into thinking you are a human user instead of a scraper. A tool that was very essential throughout the whole process was DevTools, which is built into most like browsers. Because with DevTools, you can both look at HTML and select the element, as well as look at the network usage and see how the actual GET and POST requests are structured and what type they use. Do they use forms? Do they just use headers? It's very where you cannot identify that without use of DevTools. From the beginning, we knew that we wanted to have some sort of cloud automation. We wanted to make sure that it was end-to-end and that once we set it up, it could run without our intervention. And we chose AWS as a cloud platform of choice. We were looking at both Azure and Google Cloud as well as a few others, but we did end up choosing AWS due to its generous free tier, its wealth of both internal and external documentation, and the variety of products and services that it offers. We ended up using two pretty common standard products, Lambda and S3. Lambda is great because it allows you to run your code without worrying about infrastructure at all. We could just put our scraping functions in the cloud in AWS, set up a cron job, and we didn't have to worry about any sort of provisioning or any sort of startup or at all. It was just very simple to use and very powerful. And to store the data in the cloud, we used Amazon AWS's S3 buckets, which are very nice because they do have simulated file systems. This is because we ended up scraping our data just into JSON files, and then we sorted by date scraped in our bucket. And it can also host a static website, which is how we display our information for the final site. On the next slide, you can see the AWS diagram, which basically just goes over how it all works. First, the CloudWatch event starts the function, then the function runs and makes a JSON file of the data, and then the file is uploaded to the data, and then the static website simply saves that, allows the data to be interactive with the user. And here you can see just some Lambda and S3 views. The two screenshots on the left are both the folder and day-to-day use, and the one on the bottom is just what each day looks like, and it has the individual jobs that was scraped from that day. And the screenshot on the right shows what you see what you get designer of Lambda, how it works and how we set it up. We just packaged all the dependencies into one zip file, so we didn't have a use for layers, and we just set up cron jobs via CloudWatch events.
As part of building a website, we needed a user interface for people to interact with. The data is no use if it can't be easily viewed. We needed something that would be able to sort and filter the collected data because there's a substantial amount of data we're collecting every single day. We basically created a static website hosted on the S3 bucket. This is powerful because we can then asynchronously access the data. This means that the data is always kept live no matter when you access the website, even if the data isn't actively maintained. Additionally, it makes loading times nice and fast, so users who come to the site, even if there's vast amounts of data being presented, won't face slow loading times because it's loaded in gradually as it's needed. On the next site, you'll see an image showing what the website looks like. It's a fairly simple table. There's links in the table such that you can go and access the source material for any listing that you find interesting. Next, we're going to talk a little bit about what we learned. First of all, with the scraper development, we learned a lot of basics when it comes to web scraping. We learned a lot about web spiders and actually trying to get the various pages that you need and find all the various locations. Parsing data off a web page was a major factor. XPath was useful. And we also learned a lot about following links and getting additional data and additional listings. A lot of websites have multiple pages of data such that it doesn't have to be loaded in all at once. But that means that when we go to scrape it, we have to go through each page to get all the data we need. Another thing we encountered a lot was anti-botting protections. One of the most powerful tools we had was Proxies. These disguise the source of your request, which is pretty important coming from AWS because a lot of those IPs are well known to various servers, including Amazon, considering they own it. Another useful tool was just switching user agents with each request. We found this to be surprisingly effective at delaying various websites from throttling our requests. Deployment to the cloud was also difficult for us. Each person had a virtual environment set up on their machine, which made it easy to develop, but getting that environment up to the cloud and all the dependencies needed did prove to be difficult. That was one of the reasons that we really liked Lambda, is because you could just set up your scripts there and set up a little environment in AWS, and it would run as if it were running on your machine. As for S3, we simply created a simple file structure. Each folder represents a day of data. Inside each folder, there's a different file for each data source that we scrape.
And then now we're going to talk a little bit about our future work. What's next for Scoutsman? We aim to web scrape data off different web pages that aren't exclusively e-commerce, such as Amazon or eBay. We want to look into hospital data statistics, especially during right now during the pandemic, as well as job listings because of the increasing unemployment rate, as well as police and crime data because of the controversy over racist crimes and acts by the police.
So for our next project in a more technological sense, we really like the foundation that we built upon, but we do need a bit more sophistication, especially in the server and what technologies we are able to leverage after escape. So our ideal architecture for a next and bigger project would be having a similar Lambda function started by a CloudWatch cron job, and then from there, the Lambda function would not scrape anything, but it would simply start up an EC2 instance. EC2 instance is a generic virtual private server, but it has access. It's much more of a Linux OS than a Lambda is, and that is necessary for Selenium, because Selenium needs a full-on browser and a web driver, which are both decently large files, so they cannot fit within a Lambda instance. But after that, the EC2 function would be very similar. It would just go via the Selenium and then save it into a JSON and then upload it to S3. And then the EC2 instance would auto terminate on completion of it running. And then if we do want to go even further, we might investigate using various databases instead of sorting by date and using JSON files for different sites, which might be both more efficient and will increase our technological abilities.
Thank you everyone for watching. You can find us here with our contact information, and you can also visit our product on the Scoutsman website. The link is right here on the screen. Thank you again for watching, and have a nice day.